All right, so in today's lesson, we are going to talk about triangles and their different pieces of what could be triangles and parallel lines and some different proportionality theorems as far as things go when we're talking about within triangles. So the first theorem that we have for today is what we call the triangle proportionality theorem. What the triangle proportionality theorem says is that if a line parallel to one side of a triangle intersects the other two sides, and it then divides them proportionally. So if you look at this drawing, what this essentially says is if we have this triangle and we've got a line that intersects here, that this top piece here, let's give it a distance of 4. Over this bottom piece, let's call it 6. That is going to be proportional to the other side. So if this is not necessarily 4, but let's say that this was 10, we could find the value of x. They don't have to be the same, but they are proportional. So since they're proportional, what this theorem says then is because that's parallel, we could say that the ratio 4/6 has to be equivalent to the ratio of 10/x. So kind of you use the intersecting line, that's kind of your division line, so to say, and you put kind of this equal sign in between it. Okay? And it's always going to do this as long as these two things are parallel to each other. Now we can cross multiply. 4 times x is 4x. 4x is equal to 60. Divide 60 divided by 4, and you get x is equal to 15. So that means that this part of it would be 15. Okay, and that's what we call the triangle proportionality theorem. Essentially says that AE over EB is equal to AF over FC. Okay, let's look at a second example. So given this triangle, there are our parallel lines. It wants us to find US, which is that distance right there. So I'm just going to put an X there. So the ratio is part to part, so 14 over X. The 10 goes along with the 14 over the 4. So 10x equals 14 times 4 is 56. So x is equal to 5.6. And there's nothing wrong with those types of answers. Okay, let's look at another one. I think it's this one. Okay. So in this case, why don't you pause for a second here, see if you can find the value of x. Okay, so I'm going to just go from the point. So x over 5 equals 9/3. If you would have gone 5 over x equals 3 over 9, notice that this is 3x equals 45, but notice this as well. It's 3x equals 45. So either way you wrote it, it's okay. You're still going to get 15 as your solution for x. And you're done. Okay, that's the triangle proportionality theorem. The next one is what we call the two transversal proportionality. And this isn't just with two. I mean, you could add layers upon layers upon layers for this. I could add a third line in there. It says if 3 or more parallel lines are cut by two transversals, then they're divided proportionally. So essentially, we've got these two lines here being cut by 3 parallel lines. So these are all parallel to each other. Essentially what it's saying is that if I put a 4 here and a 10 there, that I can write the ratio 4/10 and say I put a 6 here and an x there, that's going to equal 6/x. They're going to be proportional to each other. Cross multiply, 4x equals 60, x is equal to 15. And you're done. It's kind of that, again, that proportionality piece of it. You can break them into little pieces. Okay, so let's look at this one. Again, we've got our parallel lines cut by our transversals, and our parallel lines are there. So I'm just going to run along this transversal. So I'm going to put 16 over 12. And then since I was 16, the 16 and 13 are in corresponding spots, so I got to go 13 over x. So 16x equals 12 times 13. 156. Divide that by 16. You get x is equal to 9.75. And again, if you wrote it differently, if you went 16 over 13 equals 12 over x, notice you get the same thing. 16x equals 156. As long as you go the corresponding parts over the corresponding parts, it's going to work out, okay, when you're doing these. Okay, so let's look at one that's a little bit more in depth. So in this case, we've got this big, huge thing, and notice there are more segments, and so there are little 3 segments within this one. We've got 3 segments on the top, and we've got 3 segments on the bottom. And when you've got 3, you really have to have one of them set up. So ultimately, we're going to have to find LM and MN, so I'm going to put an X there, and I'm going to put a Y there. So I'm going to find X first, so 4.5 over 2.6, that's this over this. That's going to equal 4.9 over x. Cross multiply, that's 4.5x equals 2.6 times 4.9 is 12.74. Divide that by 4.5, and you get your x is equal to 2.8. That's your x value. If we wanted to find the y value, I'm still going to use the 4.5 over 2.6. I'm sorry, I'm not going to use 2.6 this time. I'm sorry. I'm going to go 4.5, and now I have to find the y value, so that's 4.5 over 4.1, and then that corresponds to 4.9 over y. So 4.5y equals 4.1 times 4.9. That's 20.09 divided by 4.5. You get 4.5. Y is equal to, and it's, which is okay. And it's going to be pretty close in that case. It's a little bit higher than that, but somewhere right in there is what it's going to be proportionality-wise. Okay, and that's just our y value down there. So that's kind of the second set of problems that you're going to have for today, is kind of those different pieces. And again, just kind of correspond them with different pieces. We'll come back to this one at the end. The last theorem, the triangle angle bisectors theorem, says is that if you have this triangle and there's an angle bisector in there, that this breaks it up into proportions. And I'm going to say that this is 4 and this is 6, and let's say this is 10 and this is x. Now, I do it a little bit differently than they do it. They would say, if you go by their definition, they're going to say 6 over x, the 2 bottom pieces. The 6 has to go with the 4 and the 10. That's what they're going to use. I don't like to do it that way. I like to do the left-hand side as a proportion and the right-hand side of the proportion. So I like to go 4 over 6 is equal to 10 over x. And if you look at it, you can see that it's the same thing. This gives us 4x equals 60, and this gives us 4x equals 60. And in both cases, then you've got x is equal to 15. I like to do it this way. It's just because it keeps it on the left-hand side. Top over bottom is top over bottom on the left-hand side of the bisector and on the right-hand side of the bisector. And I just find that to be a little bit easier. So if we look at this one, so we've got 3x plus 3, so I'm going to use that one first. So 3x plus 3, I'm just going to go to the left-hand side. That's over x plus 6. That's going to equal 16 over 12. Now we cross multiply. So that's 12 times 3x plus 3 is equal to 16 times x plus 6. It's your means times your extremes. Distribute, that's 36x plus 36 equals 16x plus 6 times 16 is 96. Subtract 16x, that's 20x. Subtract 36 from 96, that's 60. So you get x is equal to 3. But again, just that means times the extremes when you're doing these and these different types of problems. Okay, so let's look at another one. Okay, so again, I want you to press pause on this one and then go ahead and do it and then press play. Okay, so you should have got 30. Now, again, it's kind of one of those things. If you went x minus 2 over 32 and then put x plus 5 over 40, it's the same thing. Okay, so you just got to be careful. Make sure you put corresponding sides on the top that are corresponding and corresponding on the bottom, and you should be good to go with this. The last one I want to look at is this one right here. Okay, and kind of this proportionality thing kind of holds not only when you've got the sides, so we could find y here because those are all parallel to each other. We could go ahead and find the other ones using proportionality as well. So for number 17, we're going to find 18 actually first. So 18 is a side of a triangle. So this was our first one. So we said 4 over 2 is going to equal 6 over y. So 4y equals 12, y equals 3. So now I know that distance is 3. And now the thing about this is we can write proportionalities with sides and with kind of the bottom piece too. So I'm going to take this whole triangle right here, and I'm going to take the side of that red triangle, this distance right here, and I'm going to put that over 13. So I'm going to put 10, 11, 12. So I'm going to put 12 over 13. Then that is going to equal, we're going to find x in this case. So this side, the side 12 corresponds to that side right there, which I know is 6. So that's going to equal 6 over x. Okay, so kind of that long side over its bottom is going to equal the long side over the bottom. So that's 12x equals 78. X equals 78 divided by 12, which is 6.5. So that's our value for x. Okay. Now let's find z. So with z, I'm going to use this 12 over 13 again. But now I'm going to use 4 over z because the side of that one is just 4. So that gives us 12z equals 52. 52 divided by 12 is 4.3 repetin. And that's going to be my z value. So this all really comes out and about to being able to kind of write those proportions with those corresponding parts. So 3 theorems really today: the triangle proportionality theorem, the 2 transversal proportionality, and the triangle angle bisector theorem. Homework is in there for tonight. I think you're going to find out that I did several of them today for you with inside of this assignment. So have a great weekend, everybody. See you next time.